All right, guys, this is section 6.5 on rational exponents. That is still a low definition picture of me. I'm not shaving or getting a haircut until I'm allowed to go outside and play. So the first couple of slides here. Now, first of all, rational exponents, what is that? That would be something like, well, anything that can be expressed as like fraction or a whole number could be considered a rational exponent. Yellow today? Oh, maybe. So first, let's look at 1 over n. So a to the power of 1 over n is the nth root of a. So a to the power of 1 over n is that root of a. N's got to be a natural number. That's just like 1, 2, 3, 4, etc. And it's got to be greater than or equal to 0. I'm going to give you a couple examples of that, and already I am not liking my pen color. So let's switch it to black. Yeah, that'll do. So what I mean by that is that a to the power of 1/2, for example, that is equal to a square root. All right. We don't usually put the 2 there, or nobody that I know of puts the 2 there, but really when you're taking square root, there should be a 2 there. A to the power of 1 over 3 is the cubed root of a. A to the power of 1 over 4 is equal to the 4th root of a, and so on and so forth. All right. On your calculator, you can actually type it in either way if you're evaluating these. Now, I'm just scribbling here underneath. If you guys are taking good notes, if you just have that, then that's good enough. I'm just kind of spitballing here. In your calculator, if you were to type in A, and then on my calculator, the exponent button is this button right here, and then I went bracket 1 divided by 4, or even use the fraction button, 1 over 4, and then it equals, that'll work. Just as well as, let me find where my root button is. Right there, it's a root X button. So if I go A, and then I hit my calculator, it's second function, Casio 991, and it's this button right here, and then I can put in any root that I want. That should work also. You'll have to play around with it because everybody's calculator is going to be a little different, but that's how you can evaluate these things. The other concept that we'll look at today is m over n. So any fraction, not just 1 over 2, 1 over 3, 1 over 4, 1 over 5, but it could be 2 over 3, 3 over 2. Those are all valid as well. So the definition of a to the power of m over n is equal to the root n to the power of m. Root n to the power of m. M has to be an integer, and n has to be a natural number. A has to be greater than 0, greater than or equal to 0 if n is even. So before I get into specific examples, I'm just going to look at that a little bit with you guys. So a to the power of, let's say, 2/3. What is that? Well, that is equal to, it's quite easy to figure it out. You would call this the rational. And then to write it as a radical, the 3, the denominator is the root. So it's the 3rd root of a to the power of 2. And this would be called writing it as a radical. Radical. There we go. Rational, radical. Rational, radical. I'll show you just one more here. I don't know, a to the power of 5 over 3. Again, it's going to be the 3rd root. The denominator becomes the root. And the numerator, the thing on top of that fraction, is the exponent. Rational, radical. Rat and rad. Now let's do some specific examples. So these ones I'm going to actually evaluate. So it's written as a rational exponent. So that's going to be I'm going to put the 2 in, but on your calculator, you're just doing the square root of 49. Square root of 49 is 7. I'm going straight down. 32 to the power of 4 over 5. All right, so that's going to be equal to the fourth root of 32 to the power of 5. And that's how I'm going to punch it into my calculator. So I'm going to go 4, 2. Let's see if that works. The exponent 5. And it equals 16 if you type it in correctly. 16. Top right, I've got negative 64 to the power of 1/3. So that's going to be equal to the third root of negative 64. It's okay because it's the third root. And I'm going to type that in right here. I actually have a button that's third root. So I'm going to go third root 64. I mean negative 64. And it's equal to negative 4. If it was square root, it wouldn't have worked. Because you can't take the square root of a negative number. Last one here, 0.04 to the power of 3 over 2. So that's a square root of 0.04 to the power of 3. The 2 means we're doing square roots, and the 3 on top means it's to the power of 3. So I'm going to go square root of 0.04 to the power of 3, and it gives me 0.008. Zero decimal 008 on my calculator. You guys can double check my work if you're following along with your calculator and make comments as needed if I've messed anything up, but I think we're good. So in these ones, you have to solve for x. This is kind of the second skill that you're going to need to use these for. So just like when we have things that are squared, like x squared equals 4, to solve that, we go x equals the square root of 4. We use that one all the time, the whole squared to square root, but it works with any of these fraction exponents or any of these rational exponents. So if I want to move that over with the 16, I got a fourth root both sides. All right, so I'm going the fourth root of 16. Another way to express that, if you just want to do it with exponents, is that if you've got x to the 4, then it's 16 to the power of 1 over 4. So if it's 4 on the left side, it's 1 over 4 on the right side. And you can kind of choose what you want there. At the end of the day, you're going to realize, okay, 1/4, right, that's going to be fourth root of 16. And I'm going to type that into my calculator right now, or I'm going to attempt to. 4 and it equals 2. The fourth root of 16 equals 2. Double check your work. 2 to the power of 4. Does it give you back 16? Yes, it does. This guy down here, same idea. So if I want to move that over the equal sign, it's going to become the square root. That's what I did with that 2 on the bottom, the denominator. And then, oh, but I have to flip it. I messed that one up. All right, 27, 2 over 3. There we go, right there. So it's the third root of 27. That's what happens to the 3, and then squared. So I'm going to take that cube root first of 27, and then I'm going to go power of 2, or squared, and it equals 9. And just double checking that works. Both of those work. So those are the two main types of questions you're going to get today, is just evaluating. Now, sometimes you just have to simplify, and it says don't evaluate, just leave it. Like sometimes you'll be asked just to leave it like this. Sometimes you'll be asked to leave it like this. If it says evaluate it with your calculator. In this case, you have to solve for x. Now, what else do we have to do? Oh, yeah, problem solving. So under annual compounding, the principal of $900 grows to $1,200 in 4 years. Determine what the annual interest rate is. Well, here's the formula. So P stands for the principal, that's the money you start with, and A stands for what you end with. So you end with $1,200 and you start with $900. Inside, I've got 1 plus the interest rate. That's what we want to find in this problem. And it says it's happening over 4 years. So the first thing you got to do is divide by 900, both sides by 900. So I go 1,200 divided by 900, and I get a value of 1.3 repeat. I'm going to leave that number on my calculator. I'm going to put that there in case I lose it, so I remember that it's repeating. And on this side, I've got 1 plus the interest rate to the power of 4. So what do we do with that 4? That's the next thing we have to figure out what to do with. And just like in one of our last examples, if it's to the power of 4 on the right, then it's going to be to the exponent 1 over 4 on the left. And then I'm just left with 1 plus I. So right now on my calculator, I've got 1.3 repeat still sitting there on my calculator. And I'm going to type in to the power of 1 over 4, or I can say the 4th root if I want to. So I'm going to continue over here. After I did that, I got 1.07 and a bunch of other stuff is equal to 1 plus I. There is one more step. I got to subtract 1 and subtract 1. If I subtract 1 from that 1.07, then it's going to give me 0.07. I'm going to put one more digit and I'm going to round it. 5 is equal to I. Now that is your percentage in decimal, which is fine. But the interest rate, usually we say it in a final answer, I'd want that as a percent, which means you just multiply the decimal by 100. So it will give you 7.5%, right? Either of those answers sounds good to me. But that is how you go about solving that exponential function. You could have used over here, if I just switch to red for a second, over here, I could have, instead of going to the power of 1 over 4, I could have did the 4th root to solve for that, and it would have given me the same amount. Anyways, that's how you can solve a problem using interest rates. Actually, our next chapter is on finances, which we won't start for a couple of weeks, maybe first week of June, something like that. But that's the types of questions you're going to be asked to solve today. It's all on this page right here. And as you can see, number 1 says determine each value without using a calculator. So you're just looking at taking square roots, right? 1/2 is all square roots. Square root of 36, square root of 144, square root of 81, square root of 0.25. You know, nothing too crazy there. If you need to use a calculator to check your work, that's fine. Determine each value without using a calculator. Third root, third root, third root. 1 over 3 is always the third root. Again, use a calculator if you have to. Number 3 says rewrite each expression using rational exponents. So like the square root of 64 means you write 64 to the power of 1/2. That's all it's asking you to do there. It's not asking you to evaluate it or anything. It just says rewrite the expression using rational exponents, just testing on whether or not you can take these roots and turn them into fraction exponents. All right, rational exponents. Number 4 says evaluate them. You can use a calculator for that. Number 5 says determine the value of each expression. They're all different roots, so that'll just get you used to using those buttons on your calculator. Now, another way, if you're not comfortable using that root X button on your calculator, then 16 root 4 of 16 is to the power of 1 over 4. So an easy way to punch that in your calculator is to go 16 to the power of, that's what my exponent button looks like. Some people say y to the power of x. And then I put a bracket, and then I just type in 1 divided by 4, or 1 over 4. Then you hit equals, and it should give you 2 if it works out. Give that a try on your calculator, and that'll tell you if you're on the right track. And then you can do the same for all of them. Number 6 says write each expression in radical form and then evaluate without a calculator. Again, if you can. I'm not sure why we have to do that without a calculator. I'm not going to be checking for that. So, for example, 243 to the power of 1/5. The rewrite is just fifth root of 243. Now, I can't do that in my head. You'd have to guess and test to try and figure out what value that would be. But that's what it means to do. And then they get more complicated, like f is negative 32. So you'd be going negative 32 to the power, or rather, the fifth root, because that's in the denominator of to the power of 3. That's what it wants you to write it as, and then figure it out. Evaluate without a calculator, though, is maybe a bit of a stretch. Just do what you can do. And I mean, that's the way it goes, guys. You're going to have to think a little bit when you're looking at number 8. I'm only having you do 1 through 8. There's a few pages of questions, but I have decided that I can evaluate whether or not you know what you're doing if you can do 1 to 8 and 1 to 8 only. So it's on page 376 in your textbook. I think I've already attached a picture of the work to this post. If not, you can always just pause the video right here and it shows you what all the questions are. As usual, attach a picture of your work and hand it in and keep going. There's only 5 or 6 weeks left to school, guys. So just keep up the good work. Keep the questions coming via email, and I'll get back to you as quickly as I can. All right? Good luck.